The team of welders now gets to work. First, however, the powerful 200-ton crane positions the next section of pipe on the ramp so that it can be welded onto the other section. There are always enough pipe sections available on deck to cover at least 2 shifts. There is another vessel moored alongside which provides the necessary stock, and the pipe sections are carried onto the Mario Primo deck using the main crane. Staff on board mark lines on the pipe sections where the technicians have decided that the harnesses should be put on to lift them. The Mario Primo has a remote control hydraulic manipulator. It's a 3-piston device which can move a piece of piping. With this device, once the new section has been positioned on the ramp, the part of the next section to be welded can be manoeuvred into position. A specially qualified worker then moves the end of the pipe into the correct position so that it will have a precise fit with the previous one. This is the most important phase, and then the pipes are actually joined together using an electro-pneumatic welder, which is placed inside the pipes. Before matching and soldering the various bits, however, they need to be carefully prepared. The workers in charge of the soldering make a great job. The team leader then oversees the actual joining of the pipes. This is a very delicate phase. The axle of the pipe must coincide perfectly with the axle of the span already positioned. To ensure that this happens, there is also the possibility, as we said before, of varying the angle of the ramp, which is controlled by an oil dynamic pump, until the 2 axles coincide perfectly. The span, whose length varies according to the bathymetry, is made lighter by floats called Flotex, and this avoids placing too much stress on the span itself. The floats are positioned by the divers under the supervision of the team leader. The divers position the floats at the exact points indicated by the experts at research. When the pipes have been joined, a track is fixed along the perimeter of the pipe near the soldering points so that the remote controller welding machine can run along it. The track is fixed at precise points so that the welder head coincides exactly with the point of the join. 2 remote-controlled welding machines work along the perimeter guided by experts. These latest generation welding robots are powered by sophisticated electronic equipment which provide an extremely stable form of power. The gas used is argon. The movements of the welding machine are automated. Each of the 2 welders works over an area of 180 degrees, and they make 5 different moves. The operator has to keep an eye on all the different parameters the sophisticated machine produces. To make the soldering perfect, the corridor of the ramp has to be completely closed. After the 5th move, the soldering is complete, but the job is not. The welding has to be checked. A specialised technician is called in. With a special ultrasound machine, he or she checks whether there are any problems with the soldering. This person is responsible for checking whether the job has been done properly. Once everything is given the OK, the matching sides are covered with a thermo-shrink sheath to protect the welding as much as possible, and a further layer of anti-rock material is added. Finally, the OK is given and the pipe can be laid. The recently soldered pipe goes into the water to leave space for another section. Everything has to be done to millimetre precision. All the workers must do their part perfectly. The launch is about ready. Everything is under control. Bisanti, with his VHF radio, communicates with each of the operators, and one of them is the captain of the Mario Primo. From now on, during the whole of the launch procedure, everyone has to be extremely careful. Before the laying begins, the poles which hold the Mario Primo tightly anchored are lifted using the hydraulic pistons. Keeping the left pylons firmly in position, the Mario Primo moves horizontally for 24 metres thanks to a track situated on the left wall. The two fixed poles allow the ship to move forward in a straight line, but there's no danger of oscillation, which could result from anchor movements, and so possible errors are eliminated. Now the motor vessel is free to move. It will do so by pulling up the front anchors and dropping those at the stern. A sophisticated satellite system indicates the precise route to follow. It's a GPS differential, and the aerial is on the cabin roof. Any necessary corrections to the XY coordinates mean that the exact position of the tunnel is shown on the screen. The tunnel is about 10 metres wide, and the pipe needs to be positioned centrally, though a slight margin of error to left or right is tolerated. Meteorological conditions are crucial, but the Mario Primo has nothing to fear. The Oceanographic Department at Research first takes readings of the currents. Everything is going fine. The two 15-ton pulleys at the front of the vessel pull the Mario Primo forward. At the stern, the research personnel drop the anchors. At the helm, there is maximum concentration. All eyes are on the monitors to make sure the pipe is positioned properly. Sometimes they have to make some slight adjustments. The person in charge communicates by radio with the pulley operators and tells them whether to move slightly right or left. Two auxiliary cranes, one at the prow and one at the centre of the vessel, help with the laying. The pipe slides into the water as smoothly as a dolphin. This is an optical illusion. It's the Mario Primo moving forward. The launch stops when the pipe gets to an established point. The pylons are lowered and the Mario Primo is held fast once more. And the operation starts all over again. The Pontone Fernando vessel is at least 150 metres in front of the Mario Primo. It's one of the more technically advanced vessels currently working in the Venice Lagoon. It works for Research Limited, but it's not part of their fleet. With a 14 cubic metre skip, the Fernando crane digs the tunnel necessary for the laying of the pipe. It's 3.5 metres deep and 10 metres wide. The Fernando digs day and night. The route is followed as precisely as the rest of the process. The operator follows the progress of the skip on the screen to make sure it's in the right position. A differential GPS gives the right position. The aerial is positioned directly on the crane. The operator controls the parameters on the screen, the depth and the width. On this occasion, the team leader and an underwater operator are simulating a decompression accident known as air embolism. On deck, there is all the equipment necessary to provide first aid to the scuba divers. Compressors, changing rooms, rinsing tanks and hyperbaric chambers. In the case of an accident like the one simulated here, a hyperbaric chamber on board helps to reduce the effects, especially because help is immediately at hand. It's crucial to intervene quickly in these situations. The other key concept here is ecology. All the Mario Primo engines are low emission type. While the welding cycle is repeated, the group of divers with a boat to assist them removes all the floats from the side of the pipe, which is already positioned inside the tunnel. The floats, once they are brought to the surface, are towed towards the Mario Primo ramp to be repositioned at the established points. The Fernando is working at full throttle. The Mario Primo urges it on. The men work like precision robots. The Mario Primo doubles its output within a short space of time. In the meantime, the Fernando is nearly exhausted. They start working the day shift only. Thanks to the Mario Primo, the previous target of 4 sections a day has now become 8, which means 200 metres of pipeline. Amadeo Camarota, the man in charge of the yard, sometimes comes to supervise the work. The pipe-laying work is going like clockwork. Meanwhile, on the mainland, they're working on the cathodic protection of the pipe. The images show the machine for making the hole for the dispenser. A cathodic protection system produces a low-voltage current with sufficiently low amperage to avoid the effects of galvanic or direct currents. The long cable the technician inserts in the hole is made of titanium anodes and is estimated to last for at least 80 years. The first bit of land the pipeline goes through is the Venice Lagoon. It then reaches a well in the Lido and from there joins the undersea pipeline. Once this undersea pipeline, which is part of the integrated Fusina project, is finished, Venice can boast another major contribution to the reduction of the harmful effects of pollution.